Okay, good afternoon. I think this qualifies as. It is day 50. Shouldn't have started doing this hand thing, but day 50 of coding every single day until I am employed by a tech company. So, as you can see, little change of environment here. Like I said, I was gonna go home. Um, I want to show you something actually real quick, then I'll get back to the intro of what I'm working with right now. Well, this is the rig right now. Okay, I have this I built a while back. I built this with my dad, um, and I call it the suitcase PC because there's a handle up top here. There's a monitor that fits in here, and then behind it's a motherboard, GPU, all this, and it's like you can just carry it around, right? It has everything. It has everything. You just have to find an outlet, plug it in, and then plug in like a keyboard and mouse, right? Um, so so yeah, this is what I'm working on right now. Um, and you may be like, where's the camera? Well, you can kind of see there's like a little sponsored tag here. I have my iPhone running an app that is over the Wi-Fi sending video to an application, this application, and that application is being captured as a source on OBS. So don't say I don't try, okay? So I got this janky rig set up, and also, so I usually have a button that I press for. I bought this it's like a 10-foot long wire that has like the power source and the RGB inputs, and then it's a tactile like blue switch button to turn on PC. And I left that at my apartment because that's what I use for because it's just convenient to have just a button on top of my desk because my PC's under my desk. And so I had to take this old PC case. You know how there's like wires that come from all of this, like, this bunch here for like USB actually turning it on, and that I took just the power source one. You can kind of see right there. One of these cables is leading in there, and that's the power. So I press the power button on this case and it turns this on. So, and then I have a Kinesis usually for keyboard, but I bought this a while ago, which is like a small travel one, and the keybinds are different from my Kinesis, so bear with me today. I'm like trying to relearn the keybinds. I did do a remapping for this PC of a couple keybinds, but there's some that are like layer control. So like because the keys, there's no numbers on here, right? So I have to hold down this like center button on the thumb cluster, and then this top row turns into numbers, and then if I hold down center button shift, all this turns into symbols. Sorry. So bear with me today, and by today I mean one LeetCode because it's kind of already scuffed and I haven't eaten today and I want to go eat. So yeah, and this phone probably will die if I do more than like an hour. So yeah, so I just want to show you what I was working with. Okay, so yeah, home for the weekend. Chiefs Texans game starts in 30, and I want to watch that as well. So we're gonna get right into the LeetCode for today. Yeah, trying to think anything else. Oh, I got a what do you call it? OA, but I forget what OA stands for. A coding assessment. What does the O stand for? I know it's assessment. Um, I forget what O is for. But anyways, I got a coding assessment for Chewy, like that dog brand, for an internship. And I looked it up, and it looks like it's 12 Java questions. So I'm gonna take tonight to like review over Java knowledge and what that code and syntax looks like, and Java specific stuff. And then tomorrow, either morning or afternoon, I'll do the assessment. And yeah, hopefully I do good on that. And then it does seem like their interview process is pretty rugged. It seems like you do an OA into a one-on-one behavioral into a one-on-two technical, and then you go to their headquarters in Boston and you do a panel, which is, you know, HR, recruiting, and engineers, and it's behavioral and technical questions. So yeah, but that's the only update on the last, oh, I don't know, 100 apps we put in this month. So, so yeah. Anyways, let's get into it. Not sure where we want to be today. So greedy. So this is just like search stuff, right? Maximum subarray. What's this? Given an array integer. What does this look like, by the way? Yeah, I am blocking like quite a lot of the screen, aren't I? Is that good? Oh, that's good. Maximum subarray. Given an array integers nums, find the subarray with the largest sum and return that. Is this not just sliding window? Is a non-empty sequence of elements within an array. Okay. I'm assuming one of the ways to solve this is, it says greedy though. I would assume okay. So obviously I want to do a sliding window here, right? Because that's pretty obvious, is we want to just keep growing and shifting and whatnot. But how do we want to grow and shift here? So should it be off of, so if we, obviously we start at 2 and we go to -3 and we're at -1, right? And we go again and we're at 3, right? Oh wait, given a, find the subarray with the largest sum and return, oh, return the sum. Okay. So I'm assuming it's 4, -2, 2, 1, -1, 4, right? That'd be 2, 4, yeah. So, I mean, the most brute force way you could do this is you start with a static window size of 1 and you go through and you compare the current sum of the window to the max sum, and you go through again, increasing it, increasing it, increasing it, increasing it, increasing it, and that's it. So we can implement that first, right? And then kind of optimize from there. So what's going to happen is we're going to want to go through this array n to n to the power of n, because if we have 1, 2, 3, 4, 5, 6, 7, 8 elements, right? We want to grow to the size of 8, right? So we'll do 1, go through, 2, go through, until eventually we have the whole array. Okay, so we're going to want to do a for index in range. Oh, what is the curly bracket on this? Is it going to be center this? No. There we go. Okay. In the range of the length. In the length of nums. So length of nums 1, 2, 3, 4, 5, 6, 7, 8. Yeah. Okay. So that's what we want to do. I don't have any arrow keys on this. At least I don't know where they are. So we have to do that. Shift enter. Okay. So and then here we're going to want to do, we want a max sum, right? Which is equal, where's my equal? Is that equal? It's not equal. Oh God. Oh God. I feel like it's gonna be like over here. These are all numbers. Bear with me. I can't find an equals. What? Okay. We're gonna have to copy paste an equals. This is so stupid. Okay, I'm gonna have to figure out this. And also, so on the kinesis, it's like I'm pretty sure it's space is here and enters here, and then backspace here and delete is in one. On this, I have to have my thumbs here, and this is space and this is delete because the center ones are, I just can't remap them, so I have to jump like this. It's just awkward. Anyways, what did I have? Equals. Whoa, 0. Okay. So this is going to so this is just how many times we're going through. We're never actually using index. Now what we want to do is we want sorry, is we want well, usually traditionally what sliding window is, you take 2 pointers. You'd have a pointer here and a pointer here, and you look at everything from here to here, and then you just increment both pointers, and then you look at here, here, here to here, here to here, that to range. So what does the code for that look like? We probably want to do oh, well, I guess it's going to be the right pointer. Oh no, the left pointer. I'm just spitballing here. Is going to be equal to 0 every time. And I would say what right is equal to index. If we're just growing every time, so like right now, this would be equal to 0. So we'd want +1. I don't know where the plus is on this keyboard either. Please tell me there's a plus. No. Okay, tell me there's a plus. Yep. I'm not looking. Okay. +1. So the window's just going to keep increasing every single iteration. And what we want to do is we want to just take this window and increment this window and look at every element between left and right. So we want a loop well, first we want a loop that's going to step through in range of for index and range of this. And so we want it to be we want it to be from the range of what index to the length of nums. And it's not like we actually need the number for that. So it's like for, I don't know, point in the range of index to the length. I gotta do the length of them, right? Oh my god, I have to do that. Okay. Right? So like here it'd be from 1 to there. That many times I want to just look from index 0 to index 1, which would just be index 0 I want to look at. So it's inclusive of the right pointer, but not the left. I haven't done sliding window in so long. This shouldn't be this hard. So the whole idea is that we'll loop through here and we'll check. We'll do another loop in which we're looping from I'm back, sorry. Parents came in. So so what do we want to do here? Okay, let's go through what I'm trying to think of right now, right? So we have an array, right? And I want to check every single subarray possible. Obviously, this is inefficient, but we're going brute force here, right? So to accomplish this, we're going to have you know what's actually better? I was gonna do checking each subarray at each given index. So it'd be like checking all these indexes, then checking the 2 here, and then the 2 here, shifting down, the 3 here, shifting down. What I can do is I can just start at one index and just grow and just check current sum at all spaces, and then compare that to max sum. That's actually a much better approach, right? Because technically it's not a sliding window anymore though, which is fine. Usually sliding window is when you're trying to find like a static sized like window, I guess, right? It's like, oh, find the biggest sum given k, right? And k is like 3, and so you want a size 3 window, and you just slide that across the array and find that. But here it's like given any one. So what we can do is we can say, okay, starting at the start index, we want to take everything from this index, so inclusive start, up until the end of that array. And then we're going to take the current value and add it to that sum. And we're going to go, start moves, and then we just do that. And we just, okay. So this should be fairly easy. So I don't need this anymore, right? But we're going to do like, so this is going to be our start, right? And then we want to do for, I mean, what is this? This is tracking like the end. So we want to do from everything from whatever the start value is until the end of this, right? And I guess what, for each value we're going to want the current sum. So this should just be resetting every single time. Where's copy? What? Am I blind? Okay, I can do the stupid command. Maybe I'm blind. Okay, but we have this, right? And it should be so we want to say that the current sum is going to be equal to or plus equal to, oh no, we have to go and we have to find I want that. I didn't look, trust me. Okay, that is equal to end, nums at end. Oh no, what is bracket? Oh, thank God. Thank God. I need to learn this keyboard before tomorrow's video. Oh. And this should be nums at end, right? So if end is from start, and start should be inclusive. Current sum plus equals nums at end. And we should go through and it should be like, okay, the current sum is equal to this, and we want to say that the max sum is equal to, again, I don't know why I keep doing that. Oh no, is equal to the max value between, no, control Z, nice. And then it's that, yeah, the max between current sum and max sum. Is that it? Or am I missing some stuff here? Let's do, we want to return, we want to return our max sum at the end. So we start here at 0, and we have a current sum of 0. And then we say, okay, for end in range of start to the length, right? The current sum is going to be equal to plus equal nums at end. So we have this. And then that's our current sum, and max sum is equal between that and that. Oh, the one thing is this should be, because we're dealing with negatives, this should be negative infinity. I should just be able to, how do you do that again? It's like, oh God, it's like, oh. See, it always does that. I need this. There's copy, but no paste over here. Okay. Right? I'm pretty sure that's how you do that. So this is negative infinity. Let's just run this, see if I get errors. Between str it's because of that. Python. Oh, float. I have to specify as a float. Nice. Yeah, that's pretty easy. Obviously, I know this is brute force, right? Because we're literally checking every single thing. We don't have to. But hey, at least, you know. Okay, so before we look at solution, what do we think a more optimized thing is here? Originally I was thinking based like expanding and shrinking based off of current sum. So like if at any point we're in the negative, right, starting from the beginning, so like looking at here, if at any point we're in the negative, we just cross this off, right? And we look, okay, not in the negative, we're at 6, right? We're at 7. Huh. I'm trying to think actually. Could that work of like, if we're ever in the negative, shrink the array, right? So right here, we're in the negative. And so, I mean, technically, if we just checked every single time we added to max sum, we would end up getting what we want to return. But like, let's say this didn't go negative. Let's say this was like -1, right? And so we go to 1, and then we go, yeah, see, so we go to we go to 1, and then we go to 6, and then we never go negative, but we never find that, so no. So no. Then again, though, this whole thing would be the max sum then, right? If this was -1 and we went to 1, right? Then we'd have 1. We'd have 5, -3, 5, 6, 5, 9. We'd have 9. And here we have 8. So it would be the max. But it's just definitely not it. Okay, let's just look at solution because I do need to go and watch that game. I need to. Brute force. I'm assuming this is just what we did. N is length. Res is the first number for I in range of n. Current equals 0. Yeah, it's the same thing. A double for loop. N squared. So now recursive. Ew. What is that? Okay, can we change this music? Okay. Thank you. Annoying music, bruh. Okay. Dynamic programming. Ooh. Memory. So it seems like dynamic programming just always has memory. DFS. What is this doing? Memory none, 2 for range. Y equals like nums, return 0. EP equals. Is this a copy of nums? Okay. Obviously, if we got someone's first name or last name algorithm, this is like optimal. Max sub, current sub. So nums at 0 and 0. For each number in nums, if the current sum is less than 0, set the current sum to 0. Otherwise, if it's greater than 0, add num. Wait, is this not what we were saying? Wait. Just go through each number, and if the current sum is ever negative, I was saying you just cut that off, but yeah, you could just stop tracking the current sum, and then the current sum, you just start tracking it again, and then it's just the max. Oh my god, that's what I said. 100% that's what I said. So what we have? Why did he max sub? Is this not max sum? Can I like report this? Like, there's no way this is meant to be the max sub. I'll see if I can like report this afterwards, because that's definitely like not what he wants there. Yeah, but okay. Let me just do this real quick. So we have our max sum, and we have our current sum. Oh, that's definitely why they do it though, is because instead of doing negative infinity, you just set it to whatever the first one is. Because then it just deals with all that. So, what would that make sense on? Wouldn't it be the current sum? The current sum you'd want equal to the first, right? Wait. I feel like it would be the first. No. No, it'd be the max sum. Why? Max sum is equal to, because you're just doing a comparison, so it doesn't matter. Bro, is it like, I'm trying to find, so like, obviously, you'd think it'd be down, whatever. I'm gonna figure out this keyboard before next video. Okay, so at 0 and then just actually 0. And so, is there anything else we want? I don't think so. We just want to say, okay, for each num in our numbers array, is it immediately the check? I mean, I know we want to at some point say if the current sum is ever less than 0, right? Then we just want to set current sum to 0. Oh, not what I wanted. I feel so slow on this keyboard. I mean, because I am, but oh my god. Current sum equals 0. There we go. And so we're just going to say current sum. Give me my plus equals. Plus equals nums, or just num, sorry. And then just the max sum. Oh my god, I don't know why it has that. Is equal to the max between, not what I wanted, the max between the current sum and max sum. And then just return our max sum. Let's go through this. So for each number, if the current sum is ever negative, reset it to 0. Otherwise, increase it by its current thing and then check max. Should be it, right? Yeah. Okay. Makes sense. Makes sense. Well, actually, doesn't. Wait. So the reason I said that earlier was because it was like, logically speaking, right? If at any point we go into the negatives, right? We go into the negatives here. We know that there's going to be a point over here where we're positive, right? Or maybe we don't, and this will be the max sum is like this positive or it's this negative, but we would have accounted for that. We know if there's ever a positive over there, it's going to be greater than this sum. So why would this sum ever make it bigger over here, right? Because if this was a big number that we wanted included, right, it would never. If it was negative, then obviously there's a big negative number. Why would we ever want the big negative? So we just cross this off, right? Because this, whatever this is going to be, will never, in any situation, be added to this and make that bigger, ever. So that's why you can just cross that off, and then you just keep going from there. And then you're pretty much checking every single subarray because you're not negative over here. So anything over here, because it's not negative, anything added on to something over here is going to make it bigger technically, right? Because it is positive. But if at any point this starts getting negative, right, then we know that this isn't what we want, and obviously we can't have this, or this is what we want in the center. I'm doing horrible hand visuals here. but this is what we want, what's in the center, right? And so we already have that as our max sum as we kept growing. So yeah, makes sense. Okay. So I'm gonna end there because I want to go watch this game and make some food. But fine video. I mean, this question was pretty easy. I even solved the best approach, even though I didn't code it out. I mean, the coding it out would have been. I mean, I just did it, but I did see the solution. But I mean, I would have. I'll be honest. I would have implemented as in like. I would have just taken nums up until the point of we became negative, and then like, started computing a current sum there. It is much smarter though to just have the variable tracking and then reset it. So learn. I guess I mean I already like technically knew that, but it just didn't come to mind. Anyways, yeah. So I am going to upload this and go watch the Texans Chiefs game. Hopefully it's a banger. Hopefully, I would say hopefully, but it'd be cool if the Texans actually did make that upset. But yeah, might work on my app tonight off camera, and then tomorrow morning, I think I'm just heading back to my apartment. So I'll probably just do another evening recording, or yeah, I'll probably just do another evening recording. Maybe I'll do an early recording tomorrow before I. The whole reason I came back was so my dad could look at my car and so I could go out to breakfast with my grandmother because I haven't spent time with her in a while. So before I do that, and we're supposed to get a foot of snow tomorrow, so I need to get home before we get. I need to get back to my apartment before we get that snow. So yeah, yeah, that's it. I will see you tomorrow. Take care. Bye.